Algebra 1, Lesson 61, Simplifying Radical Expressions. So right here we have two radicals and they're being multiplied together, square root of a times the square root of b. You can rewrite it together underneath the radical as the square root of a times b. The reason why we can do that is because this root right here is the same, it's 2. So you can combine them underneath the same radical. And you can go the other way. If they're underneath the same radical, it might be easier to simplify them if you separate each term. Okay, so keep that in mind. They ask us right here to simplify using perfect squares. Right here is the square root of 225. You can find, oops, I think I'm ran out of lead. Right here, the square root of 225, I'm sorry. You can use your radical because this is a perfect square, but you can also find factors of 225 that are perfect squares. 4 is a perfect square, meaning you multiply the same number together 2 times to get 4. 2 times 2 is 4. 9 is a perfect square. You multiply 3 times 3 to get 9. The same number 2 times to get 9. And actually, 9 is a factor of 225. 225 divided by 9 is 25. Okay. 9 is a perfect square and so is 25. So I'm going to rewrite these guys underneath the radical 9 times 25 because that's the same as 225. Right here they are together, they're combined underneath the radical. I'm going to go like I did up here and separate them into 2 separate radicals. Square root of 9 times the square root of 25. Square root of 9 is 3. Square root of 25 is 5. So it's 3 times 5, which is 15. Okay, same thing over here, square root of 72. Let's find factors that are perfect square of 72. 4 is, okay, because 72 divided by 4 is 18. Oops, 18. Okay. 18 is not a perfect square. It can be factored with a perfect square though. 18 divided by 9, 9 is a perfect square, is 2. So 2, 9, and 4 are the factors of 72. If you multiply them together, you'll get 72. 4 and 9 are perfect squares, 2 is not. But I'm going to rewrite it under here as 4 times 9 times 2. They're all combined. Like up here, I'm going to separate them. So I'm going to have square root of 4 times the square root of 9 times the square root of 2. Square root of 4 is 2. Square root of 9 is 3. There's not a number that you multiply 2 times the same number to get 2. Well, there is, but it's not a perfect square. So I'm going to leave it as square root of 2. The 2 and the 3 can be multiplied together. You have 6, and then times the square root of 2. And that's your answer. So you might have to simplify here. 225 is a perfect square, it's 15. 72 is not a perfect square. So you might need to factor it like we did here, finding perfect squares. Now what if you don't know what the perfect squares are? What if you don't know that 4 and 9 are perfect squares? That's okay. Just factor right here at 180. Just use your factor tree. We can do 180 divided by 2. And that is 90. 2 is not a perfect square, but that's okay. Then I'm going to do 90 divided by 2 is 45. 45 cannot be divided by 2, but it can be divided by 3, and you get 15. And 15 can be divided by 3, and you get 5. None of these, 5, 3, 3, 2, or 2, none of them are perfect squares, but they are the factors of 180. So I'm going to rewrite it here as the square root of 2 times 2 times 3 times 3 times 5. All of my factors. If I multiply these together, I get 180. Now, what I'm going to do, because up here I found factors that are perfect squares. Up here I just found, or down here I just found the factors. Any two numbers that are the same, you can put them together. 2 times 2. You can rewrite it as 2 squared or 2 times 2, which is 4. So I'm going to rewrite it as 4. 3 times 3, that's the same number, and you get 9. 5 is the only number here. We'll leave it down here. We have 3 combined. Like up here, I'm going to separate them into separate radicals. Square root of 4 times the square root of 9 times the square root of 5. We know what the square root of 4 is. This is a perfect square. It's 2. Square root of 9 is 3. Square root of 5, we don't know. It's not a perfect square. Okay, multiply these together. 2 times 3 is 6. And then under the radical, 5. We just leave it here. 6 times the square root of 5 is the same thing as the square root of 80, or 180. 180 is not a perfect square. Okay, now what happens when you have really big numbers, okay? What you can do is you can simplify these, what it says, by using powers of 10. So the square root of 10,000 right here, if you want to simplify that, rewrite it. There's 1, 2, 3, 4. However many zeros there are, that's what your exponent is going to be. There's 4 zeros. So as a power of 10, it's going to be 10 to the 4th power. However many zeros there are. Okay, you can rewrite this. That means we have 4 tens here because of the exponent. You can rewrite it as 10 squared times 10 squared. Because whenever you're multiplying 2 numbers and they have exponents, you add the exponents. 2 plus 2 is 4. Rewrite this, separate it as 10 squared times 10 squared. The square root of 10 squared is just 10 for both of them, so it's going to be 10 times 10, which is 100. So the square root of 10,000 is 100. Right here, there are 5 zeros, so we're going to rewrite it as 10 to the 5th power. This is one where we're going to separate it into separate exponents. So it's going to be like this. There's 5 tens here, so I'm going to, here's 2 of them. 2 more is 4, and then it's the 5th one. So 2 plus 2 is 4, plus 1 is 5. I just rewrote this as powers of 10. Okay, separate them. 10 squared times 10 squared times the square root of 10. We know what the square root of 10 squared is. We already did it here. It's 10 times 10. Square root of 10 is not a perfect square, so I'm going to leave it here. 10 times 10 is 100. And then we have times the square root of 10. 100 times the square root of 10 is 100,000. Okay, so again, if you're confused by having the 10 with an exponent, it's just like treating it like, I call it the base. It's like treating it if it was x squared. You can find the square root of x squared. Okay, it's just going to be x. Or in this case, square root of 10 squared is just going to be 10. Okay, now we need to simplify. All variables represent non-negative real numbers. Here we have a number or a coefficient and variables, okay? What you need to do, rewrite them under separate radicals, okay? And then see, is 81 a perfect square? It is, which is awesome, okay? 9 times 9 is 81, so this is going to be 9 right here. X to the 4th. You can rewrite it like we did up here with powers of 2. We took all the 10s and we wrote them with powers of 2. So I'm going to rewrite this as x squared times x squared. Okay? And then the y cubed, I'm going to rewrite that also. There's 3 y's, so y squared times y. 2 plus 1 is 3. Kind of like this one up here where we had 5 10s. So we did 10 squared times 10 squared times 10. This one, there's 3 y's, so 2 y's plus 1 is 3. Rewrite these guys underneath their own radical. X squared times x squared times y squared times the square root of y. This right here, simplify these 3. The square root of x squared is x. Square root of x squared is x. Square root of y squared is y. Square root of y, no perfect square, so we're going to leave it. We're very close to having our answer. Combine any like terms together. We have x and x. Since we're multiplying them, we're going to add the exponents. The exponent here is 1, and this one is 1. So 1 plus 1 is 2. It's going to be 9x squared times y times the square root of y. And it looks funny, but that's your answer. Okay? This 1 right here, square root of 162, r to the 4th, x to the 8th. Okay, separate them. 162 times r to the 4th times s to the 8th. Okay. Square root of 162 is not a perfect square. So we need to factor it. I'm going to factor it down here. Okay. See if you can find prime factors, or factors where if you multiply the two numbers together, they equal it. Okay, so we can do 162 divided by 81 is 2. Okay, 81 is a perfect square, or a prime factor. Two numbers, the same two numbers, if you multiply them together, you get 81. 9. 9 times 9 is 81. So I'm going to leave it as 81 times 2 is 162. Square root of 81 times 2. Square root of r to the 4th, square root of s to the 8th. Okay, right here. Separate them. Square root of 81 times the square root of 2 times the square root of r to the 4th times the square root of s to the 8th. Okay, 81 is a perfect square. We already found that over here. It's 9. 2 does not have a perfect square. So it's going to say as the square root of 2. R to the 4th, let's rewrite this as r squared times r squared. And then I'm going to run out of space. The s to the 8th, I'll show you how to do that in a second. I'm going to do the r's first. 9 square root of 2. R squared, square root of that is r. So times r. Same thing here. So don't forget this guy. I'm not forgetting it. Now, combine the r's. You're going to have two r's, so it's going to be r squared. What you need to do is, this is the order you need to write it in. The number, then the variable, then the radical. Okay, 9r squared. So you need to combine them. 9r squared times the square root of 2. Put the number, then the variable, then the radical. Now I'm going to bring down the square root of s to the 8th, but I'm going to rewrite it as exponents of 2. 2, 4, 6, 8. Because remember, when you multiply variables with exponents, you add the exponents. 2 plus 2 plus 2 plus 2. So we have 9r squared times the square root of 2. And I'm going to separate these guys. Square root of s squared, square root of s squared, square root of s squared, square root of s squared. Okay? Well, we know the square root of s squared is just going to be s. So we have 9r squared times the square root of 2. And there's 4 s's. Combine them together. When you multiply variables with exponents, you add the exponents. Or we have 4 s's, so our exponent will be 4. It's going to be 9r squared square root of 2 times s to the 4th. But don't write it that way. Remember, we want to bring this over here. We write our number, then our variables in alphabetical order, then our radicals. So that's your answer, okay? Another way you could do this is you can do the exponent divided by the root 2. 4 divided by 2 is 2. So your new r is going to be r squared. 8 divided by 2 is 4. So your new s is going to be s to the 4th power. So that might make a little bit more sense to you. All right? I'll have your homework up for you.